Boa noite a todos. Good night, good afternoon, or maybe good morning to some of you. Welcome to the Brazilian Tunneling Committee YouTube channel. This is our first webinar live, and we have been doing this webinar presentations either in Portuguese, most of them, some of them in English, since 2 years already. And you can follow our channel, and we have many lives there, many presentations there, many with several subjects in the topic of tunneling. And if you have not done so, please follow us, give your like in the video also, and also the LinkedIn and Facebook and Instagram. We are all over the place. Yes, and so every month we have one different presentation. We are going to start now in March, and every month we have a different topic. By the end of the presentation, I will tell a little bit what are the next webinars, and I hope you enjoy them. We have also, for the ones that are living here in Brazil, we have also presential events. We just had a very nice seminar, road seminar in Florianopolis about the Florianopolis ring road around Florianopolis in the south, a very nice island. And we will have in June another presential event. That's the WTC, the Echoes of WTC. Yes. So tonight we have a very special guest. We have here with us Mike Risping. And Mike Risping is a professional engineer and vice president of tunneling for Strata worldwide. He has over 40 years experience in the underground industry, both tunneling and mining. His areas of experience include the excavation cycle, drilling and blasting, ground support, UG, heavy equipment, and mechanical excavation. He currently also serves as the chair of the Underground Construction Association, UCA of SME. It is a member of a number of various other industry associations. He has authored or co-authored 30 published technical papers, presentations, and articles. So, Mike, I give you my most welcome, and please, the floor is yours. I will leave you with your presentation and come back later for question and answers.
Obrigado, Daniela. Obrigado. Can you hear me okay?
Yes, everybody's hearing, right? Otherwise, somebody would complain. I guess so.
Okay,
Yes.
very good.
Okay, go ahead.
There may be many other reasons about my presentation to complain, but hopefully not hearing me isn't one of them. So, boa noite, everyone. It's a real pleasure for me to be able to spend this time with you, albeit virtually, to the wonderful people in the Brazilian Tunneling Committee. And the topic that I'm choosing to speak about tonight is about advanced technologies in refuge chambers for tunneling. And I trust that you will find, as others have in the past when I've dealt with this topic, that it can be educational and expose you to things about refuge chambers that you may have thought you knew, but you don't necessarily know. So, why do we need refuge chambers? Typically, in the event of explosions in an underground environment, fires in an underground environment, gas escapes either from equipment or from the rock strata, anything which renders the underground atmosphere dangerous to humans. It could be smoke, it could be atmospheric contamination, it could even be a lack of oxygen due to the conditions. These are why we need refuge chambers. But almost as important to discuss when we talk about this is when not to use refuge chambers, because people have different concepts of what they can and can't be used for. We do not use refuge chambers for direct exposure to fire. They are fire resistant, which I will cover later, but that's not the primary reason why you have them. You do not use them to evacuate from flammable hydrocarbon gas like methane, because the risk then still exists in the underground environment. You do not use them to escape flooding or inundation. And while they do have some structural integrity, you do not use them to escape lining collapse or ground collapse or major ground fault. So just to give you a very quick overview as to why somebody from Strata is giving this presentation, Strata started in 2007, introducing its first line of emergency refuge products, and was the first company to offer an entirely powerless option. Now in 2023, we're actually the largest manufacturer of underground refuge chambers in the world because of our dominance in the US underground coal market, and in some cases in hard rock mining. This isn't well known, but we are a global leader. We have 30 years of experience, and we offer this technology to the underground industries when escape is not an option. They're meant to be proactive with regards to safety. They can offer emergency breathable air, food, and water to sustain life anywhere from 24 to 96 hours, which is what we designed them for. And for the most part, they're built for comfort and safety. And you can see in this picture here, an example of one that's built onto the side of a TBM gantry. So we can custom make them really to accommodate any space you need. So let me back away a little bit from Strata and talk about the International Tunneling Association, of which your committee is the member nation organization from Brazil. Working Group 5, which deals with health and safety in tunnel works around the globe, published a number of years ago the guidelines for the provision of refuge chambers in tunnels under construction. And I show you the table of contents on the right side, which is fairly comprehensive when you consider refuge chambers, but everything is in 16 pages. And so it's a very concise, very helpful document that if you're involved in the design of, management of construction, or maintenance of operation of tunnels, it's good to know this information. And this document is available free of charge through the ITA. Now, 16 pages, but there's two passages in the context of what we're talking about today that I really want to draw your attention to. If you look on the left-hand side, this group believes that every tunnel should have a refuge chamber or refuge chambers unless it is shown not to be necessary by the tunnel project risk assessment. It's sort of the old guilty till proven innocent, innocent until proven guilty dichotomy. In this case, it's saying you should have refuge chambers unless you prove you don't need them, as opposed to not having refuge chambers unless you prove you need them. And then this puts the burden of responsibility on the risk assessment to examine what may happen in the event of fire, load, occurrence, duration, development of smoke, etc. An assessment from the risk of flammable gas should include a review of the ground investigation data. Over on the right-hand side, also equally important, is that if you have a refuge chamber in your workings, it's designed to operate. You also have to be careful to prevent any misuse of safety critical equipment, just like you would a fire extinguisher, in this case, a refuge chamber, to make sure that it is always ready when it needs to be used. You hope you never have to use it, but in the event it's needed, it's got to work as designed. So there are inspection schedules, cleaning schedules, but one of the tricks that I wanted to tell you about is if you put a tamper-proof seal on a refuge chamber, then you know that nobody has been in it, and you can actually increase the durations of the inspections to make it easier to operate and maintain the refuge chamber. So this picture over on the right is probably what most people think of when they think of refuge chamber. This is a rigid refuge chamber. I'm going to reiterate again, they're designed to provide immediate refuge, breathable air, provide a comfortable environment in which to ride out a dangerous situation until somebody can come and get you. And as I mentioned, we can manufacture them to various configurations. They can sit on the tunnel floor. They can go on rails, which I'll talk a little bit more about later. They can be built into the gantry of the tunnel boring machines. We have flexibility. So today's refuge chambers are very different from the first ones that came out. And we call them smart because they can be connected. You can see on the right-hand side a variety of features. I'll show you some pictures. Private lavatory, food. It's not the best tasting food in the world, but it is life-sustaining. And they should always have an escape hatch so that if for some reason the main entry/exit gets blocked or somehow becomes inoperable, that there is an escape hatch for people to come out when the time is right. You can put an airlock entrance with or without purge air into it. We can make them mobile by putting hitches and wheels on them. There's air conditioning with the dehumidifying available. And there's also smart connected systems that I'll talk a little bit more about in a couple of slides. So this gives you an example of what the refuge chamber would look like inside. In the upper left, you would have typically the oxygen cylinders along the back wall beside the ventilation console. You can see the comfortable seats. You can see the escape hatch up to the right and down below. And in front, that nice red curtain separates the toilet from the rest of the refuge chamber. So when I talked about refuge chambers today being smart and connected, they're equipped with a system like our IMAX system, which is intelligent monitoring, alert, communication, and control. This allows you to have live communication to surface, either wired or wireless, video so that people on the surface can see inside the chamber, atmospheric monitoring with alarms to tell you if the air quality is getting out of standard, monitoring of the battery voltage, and also data and history logging. So in the old days when these first came out, you went into them and you just waited and waited and waited until somebody could come and rescue you. Here you have access, to more information. This just gives you a little bit more detail of what I was talking about, and also shows you what the continuous digital connected readout might look like on the right-hand side. So now I'm going to shift away to one of three other options for refuge chambers. And in this case, we're going to talk about an inflatable refuge chamber, which is partially rigid, but has a tent that inflates when you need it. We call these fresh air bays. They are air powered, absolutely standalone. You could drop them in an offshoot of the tunnel and they'd be there and ready for deployment when you need them. And they provide the same clean, breathable air in emergency situations that a rigid refuge chamber would. They're stored in a rugged, low-profile steel container. I'll show you a picture in a subsequent slide. And you don't just walk into them, but they're ready to be deployed within 3 to 7 minutes when you need them, much like a life raft from the clean air cylinders that are incorporated within the shell. So here's the shell, or what we call the skid. It is explosion and fire resistant. Like the fully rigid chambers, we can put a wheel and hitch on it and move it around. It's highly portable. That's actually one of the advantages of the inflatable one, and why a project may choose to use that, say, as an example, in the tunnel behind a TBM, because you can move it around, but everything that you need is stored within that rigid skid. Then once you inflate it, the tent is made of a durable fire-resistant fabric. It's got a double-layered floor. So while it doesn't have seats in it like the rigid one, it still provides plenty of room for people to be comfortable sitting and lying on the floor. And it does have an airlock entrance compartment. The largest one that we've ever designed accommodates up to 48 people, which, if you think about it, is much more manageable in an inflatable configuration like this than it would be in a rigid one. I'm going to play a short video here, and you'll see how it deploys. And Daniela, can you confirm for me that you can hear the audio?
Yes, we can hear.
Obrigado.
Okay.
I'll point out here that even though there are 2 people, every one of these fresh air bays is designed to be deployed by 1 person only. And there you can see it fully deployed. Now, one thing that both of these systems have in common, rigid and inflatable, is that they do have the breathing air system, which is incorporating an air-powered carbon dioxide scrubber, which uses high pressure compressed air cylinders and soda lime cartridges to remove the carbon dioxide from the exhaled air. Both have a built-in fan system, which circulates the air through the scrubber and the chemicals, and you have oxygen replenishment inside the safe environment from cylinders as needed, as regulated by a flow rate meter. So as we introduce this new technology to the tunneling industry, we often get asked what are the similarities or dissimilarities between the two. And you can see here the differences between the two. And I'll just point out a couple of points because you can read them, but one advantage of the fresh air bay is that it has a low profile height until it's deployed versus the standard structure. You still get blast resistance from the shell of the skid. You still get fire resistance from both, and you still get 24 to 96 hours of safety in these chambers. And the reason we have a broad range like that is that in most cases, underground mining legislation or companies will call for 72 to 96 hours, whereas the standard in tunneling through the ITA guideline is 24 hours. So now I'm going to go to a third option that you may have, and this is a micro fresh air bay inflatable chamber. And it's similar in concept to the FAB, but it's not self-contained. For this, you must have an attachment to an external compressed air supply at all times, because that supply is going to inflate the tent and keep it inflated and keep the fresh air circulating to the occupants. It comes in a small steel case that you see up there on the left, probably about 1.5 meters high, 0.5 meter deep, and maybe 0.5 meter wide. It can be wheeled around by 1 person. It offers a 3-stage breathing air filtration system, and it purifies the air before it goes into the chamber. This micro fresh air bay is designed to accommodate 8 people comfortably, but really in a pinch can accommodate up to 10 people. The window fabric in the airlock allows you to look outside, and that compressed air that you need is between 25 to 50 cubic feet per minute to use it. As I mentioned, it's designed for short-term use. It's ideal in the event of equipment fires, which burn out relatively quickly. It shows you above that there are refuge areas on both sides, and you've got an airlock in the middle. Now, interestingly enough, I had the opportunity to present this new concept to the head of Working Group 5 globally, Mr. Donald Lamont. And after having a chance to have a look at it, he looked at me in the eye and he said, "You know what, Mike, this is better than nothing." And he didn't mean that in a bad way. He meant that in the sense that if you either won't or can't use a rigid or conventional fresh air bay, something like this, if your space is tight, you've got a confined area, something like this will do a better job of sustaining life than if you didn't have it. And so it's now being considered by Working Group 5. Finally, coming to the fourth thing is the concept of a self-propelled refuge chamber. We're in the process of building the first one of these. They're rail mounted. We've partnered up with an international company called Mining Equipment Limited. And the idea in this case is that you have the same benefits of a rigid refuge chamber that you would have placed on the floor of the tunnel or on the gantry of the TBM. But in this case, instead of necessarily having to wait for people to come and get you, this allows you to either drive a group of people out of the tunnel yourselves or to drive into the tunnel to get people in a safe environment. These are designed to be either battery or diesel powered, 16-person occupancy, and they offer all the other features of the rigid refuge chamber, including optionally air conditioning, the IMAX system connection via Wi-Fi. And if visibility is impeded, we can also put a proximity detection collision avoidance system on this rail-mounted refuge chamber. So this just shows you a little bit more of a side mock-up of what it would look like. Up on the upper right-hand corner, this particular one is battery powered. You can see the batteries underneath the refuge chamber. Very compact. They stay out of the way. If you need to, we can build these again with diesel, but it does then either lengthen the car length you need to be able to operate or to be able to accommodate, I beg your pardon, the refuge chamber, or you go with a smaller one. And these batteries are industrial for underground environments. They operate even in harsh environmental conditions, and their capacity is such that you can do 2 full trips in and out of the tunnel to the TBM from the entrance. And if you need to recharge them, it's about 40 minutes to get back to 100% power. So not to get into too much details on these, but as I mentioned, they are commercially available, underground rated industrial batteries that would power this. And with that, I think we're right about on time, and the presentation is over, and I'll open up the floor for questions. Obrigado.
Thank you, Mike. We have already some questions. Let's see here. So everybody's saying hello to you. And let me just stop the banner here. Okay. So here, Jean-Pierre, he's our vice president as well in the Tunneling Association. So he's saying it's a pleasure to have you with us. Here, he has a question. Mike, what about a fire situation? Is that inflatable material fire resistant? How much time it resists?
Yeah, obrigado, Jean-Pierre. I don't have the stats right off the top of my head, but yes, it is fire resistant, and it has a maximum temperature and a maximum flame duration to which it can resist. And the only thing that I would add to that is that it is highly accepted in underground coal mining environments. And so we anticipate that it's going to be suitable for anything in a tunneling environment because it's designed for coal mining.
Okay. Okay. What about the chambers, like, for example, in a TBM like Istanbul, that was the crossing of the Istanbul Strait, that you had the intervention workers? Could you also use that, like the last example, for example, that you could bring them in because they needed to, for the intervention, that was like high pressure. I'm not so sure if would fit in the same way. I think not, because of the pressure.
No, I mean, typically these aren't designed for hyperbaric
Yes.
interventions, I beg your pardon. They're not designed for that. I mean, they're a place for people in which to go and lie down, but that is not Strata's expertise. Hyperbaric chambers are done by other companies that service the tunnel projects.
It wouldn't work. Yes. Yeah. And what's the current level of adoption of emergency refuge chambers globally? What's the
That's a very good question. Um, it really depends on the culture, Daniela. If you go to Europe or most places in Asia, it's almost always having the refuge chambers in the bid documents for the construction of the tunnel. They're accepted in those markets, they're expected to be there, as I kind of mentioned from the ITA guidelines, unless they're proven not to be needed, unless there are multiple egresses from the tunnels.
yeah.
Refuge chambers are part of that culture. In North America, on the other hand, historically, the use of refuge chambers has been left more or less up to the discretion of the contractors. And so while that culture is changing a little bit, they haven't been as widely adopted. And in some more third world markets, that's the same thing. I think that that may be true a little bit in Latin America as well, where they're not as accepted to be part of it yet. But what we're doing, like with presentations like this, is educating the market as to what these pieces of technology can do and why they're important.
Yes. So Jean-Pierre has another question. He's from Vale. That's a mine, the most famous mining company in Brazil. So that's why he's okay. Concerning material collapse from the ceiling ground, is the rigid model well suited for that, or it's not designed for that kind of risk?
So as I kind of mentioned early on in the presentation, and let me see, I think I'm actually showing that slide right now. It does have some structural integrity and structural resistance, but it is not designed to protect against lining collapse, ground collapse, or a major ground fall. It'll take some smaller material falling from the roof, perhaps material that comes through wire mesh, smaller blocks, but it's not designed to protect people in the event of ground collapse. It's really designed for providing a safe underground atmosphere.
Yeah, so it has to be placed in a kind of safe space inside the mine. So
Yeah, well, yes, as safe as any space can be. Like I
yeah,
said, it's manufactured of steel, so it does have some structural integrity, but it's not meant to hold up against a major ground failure.
yes, yes. And then inside the refuge chambers, I know that you can leave some like food and water as well, right? Or
We
how
we
does it
uh,
work?
we provide them. We provide them with food and water supplies and toiletry supplies that are designed to accommodate the maximum number of people for which it's designed for the design time of either 24, 72, or 96 hours.
Okay, and this timing depends on what? On the size of the type of the refuge chamber? For example, if it's 1 day or 72 hours, how it depends on the model or not necessarily?
It really depends on the legislation
Okay.
or on the judgment of the people that are operating that underground environment. As I mentioned, the ITA standard is 24 hours because of the relative simplicity of tunnel excavations. It's assumed that you're going to be able to get in from one side or another of the tunnel or through a shaft to be able to get to a refuge chamber and get people out within 24 hours. Mines can be more complex, and that's why legislation or mining company doctrine tends to lend itself more towards 72 to 96 hours.
Yeah. And is there a
Size, we can accommodate those durations with any size.
yeah. Is there a difference between United States and Canada? Do you know?
Uh, I believe it can actually vary from state to state and province to province. There are more 72-hour durations, but there are 96-hour durations in mining as well.
Yes. Yes. And that probably depends also how deep is the mine and so on. No, they would change a little bit the if you
That
are
is
really deep, then it has to be a little bit longer, no, less longer, something like
correct.
that. Yes. Okay, I guess we don't have any more questions from what I seen. I don't know if you wanted to add anything else. We will have you again later to talk more about other subjects, right? I don't know if you want to add anything else about the strata or about the tunneling world in North America, in United States, or anything you would like to add before I just tell a little bit about what's our next webinars? If you
Well,
wanted
I
to
think
add
I just mentioned,
anything.
Daniela, because you mentioned the fact that I'm not only in my day job vice president of tunneling for Strata, but I'm also the current chairperson of the Underground Construction Association, which, like your committee in Brazil, is the member nation representative organization in the U.S. We really appreciate the opportunity to interface with other country organizations. I've known many of your members over the years, not the least of which is Tarcisio Celestino. And I look forward to rubbing elbows in any international opportunity possible, including the upcoming World Tunneling Congress in Athens in May. So thrilled to have this opportunity to talk about safety, which is a passion of mine and of the company. And look forward to meeting many more of your members face to face as opportunity presents itself.
Yes, I guess we have 72 days to go. I have counted yesterday
How many
to tell
hours?
yes, 72 days.
And how many hours?
Oh, I didn't count that.
Okay, all right, no problem.
I was counting. So just to for everyone, in 1 month, on April 6th, we will have actually some ladies from Canada talking about numerical modeling, and they are from Kingston, or from where the place I have done my PhD in, from Queen's University. About its rock mechanics topic, and we're going to do that together with the CBMR. That's the Rock Mechanics Committee, Brazilian committee. And in May, Yanni is there. Yes, Yanni is participating now. He's going to talk about non-destructive methods. This one's in Portuguese. And in June, also in Portuguese, we are going to listen about the Line 6, São Paulo Metro. The Acciona team is going to present a webinar. And presential event, we have the WTC, the echoes of the WTC, that's happening just after the WTC, June 16. And that's going to be presential and also online. It's a hybrid event. So I thanks everybody for the presence. Please follow our channel, give like to the video, follow us in LinkedIn, Instagram, Facebook, and also please subscribe to our newsletter. Thank you again, Mike, and hope to see you soon here and in Greece, in Athens. Bye bye. Good night.